All right. How about this, though? How do you prove a universal statement is false?
You can give a counterexample of something in the domain that's not true.
Exactly. Exactly. So now talking about how to prove a universal statement is false, universal for x and dp of x. So to show the statement is false, right? What someone, I wasn't looking at Zoom, but someone brilliant just said is that you just need to find a counterexample. This is saying for all the x's in the domain, they make p of x true, right? In order for that to be false, right? Like what this statement, what it's saying is, it's saying, like it's making a statement about a certain quantity of the domain. It's making a statement about the entire domain. It's saying for the entire domain, you can plug it into p of x and it'll be true. So to prove it false, you have to show it doesn't work on the entire domain, meaning it just fails for one element in the domain. You have to find a counterexample. These are 4 different ways to say it. I hope it's making sense. So to show it's false, just need to find a single counterexample I'll call it x and d, such that p of x is false. So if we find a single x and d such that p of x is false, then you're going to show the whole quantifier is not true, or the whole universal statement is not true. It makes sense. It makes sense. And they're going to say, i.e., in terms of truth sets, this is saying the truth set, or i.e., there is an x and d not in the truth set of p of x with domain D. You can think of it that way. Although, really, here it's just more useful to find a counterexample. We don't really need to talk about truth sets when we're finding it false. Yeah. So let's do an example of that. So, for example, how about I was to say the statement, every student in this class is blue-eyed. So every student's class has blue eyes. What a coincidence, right? And what that would be saying is, that same thing as saying for all x students in this class let's go ahead and call this, let's say q of x equals x is blue-eyed. So we're saying that for all x in the domain students in this class, q of x is true, right? That's how we translate it into universal quantifiers. And my claim is that above statement is false. And my proof, right? Because math all about proof, right? I said all students are blue-eyed. Prove it. How do I prove it? Well, I have to. So what do we have to do to prove it?
Find a contradiction.
Not contradiction, but a counterexample. Yeah. I think your heart's still in the right place. You're trying to find a counterexample. A contradiction is something. A contradiction would be something. Oh wait, actually, technically you could do a contradiction here. That's a whole different thing. A contradiction is where you assume something to be true, and then that logically leads to something ridiculous also being true. It logically leads to a contradiction being true. It would be like if I assumed that every multiple of 3 is even, then that implies that 3 is even, which is not true. That's kind of a contradiction, kind of like that. Anyway, we should find a counterexample. So, can we find a counterexample? Does one of you not have blue eyes?
I got brown.
Someone's got brown. There we go. Proof. Safa has brown eyes. Thus, Safa does not have blue eyes. Hence, actually, probably should have noted, Safa is in this class. So Safa's in this class and has brown eyes. Thus, Safa does not have blue eyes, meaning there is a student in this class, Safa, with Q of Safa equaling false. Hence, for all x in this class, Q of x, this statement right here is itself false. Squared, we're done. Does that make sense? So this is a long-winded way of saying that we've found an element of our domain, Safa, right? You're an element of the domain, welcome, such that Q of x is false. So therefore, this statement for all x of the domain Q of x is true, that has to be false itself. Make sense? I'm not hearing no. Perfect. So, we really need a true set for that, for when we're saying it's false. So let's go over here. Let's think about this. So to show this for the universal statement is false, we just need to find a counterexample, right? Such that, counterexample x and d such that p of x is false. So for example, in this over here, we found Safa. We found there was a student that made p of x false, p of Safa, or q of Safa was false, right? What's another way we can think about this? This is a very open-ended question. So to show that not all students, or sorry, to show that not all x and d make p of x true, we're saying how much of d must make p of x false. Is that a weird question?
At least one.
At least one. And if we're making a statement about at least one thing in a set, we're saying there exists at least one thing in the set. What's that remind you of? We got some in the chat. Existential quantifier. Yes, Lauren. Yes, exactly. If we're saying this is false, we're saying that there's at least one x in D that makes P of x false. That's the only way it can be false. Right? Because if P of x is true for all the x's, the statement would be true. So, i.e., this is equivalent to there exists an x in D such that P of x is false. Oh, that's slick, right? That, I don't know which is a bad word. That is amazing, right there. So saying that a for all statement is false is really saying an existential statement, right? Saying that for all x in D, P of x, saying that statement's false is really saying for all x in D, you could think of it as, instead of thinking of it as P of x false, you can think of it as the negation of P of x being true. I mean, that's what we just did here, right? In this example with Safa, right? We just showed that there exists a student, Safa, such that Q of x, Safa's blue-eyed, Q of x meaning x is blue-eyed is false, right? Meaning the negation of Q of x being x is not blue-eyed is true. We found one example where the negation of Q of x is true. Oh, that's good. That's good. Does that make sense? So really, this is the key. This is the key here. Key idea. The negation of for all statement you know what? It's so important. I was going to start over. The negation of our for all statement. So for all x in D, P of x, this is an existential statement. There exists an x in D such that does this make sense? Because this is incredibly important. For all and there exists are opposite of each other. It's kind of like and or. Another earthquake. You guys, if you guys found out where there's an earthquake on Monday, September 14th, you'd be able to find my location exactly. So the point is, yeah. Does that make sense? Someone give me something.
Yeah, it makes sense.
Oh, perfect. Thank you, Saba. I trust you. So yes. So this is the universal quantifier. You prove it true with method of exhaustion. You prove it false with what if no values in the domain are true? Okay, Camille. So Camille asked what if no values in the domain are true. So looking at this for all x and D, P of x, if you're talking about that, if no values in the domain are true, that means every value in the domain must make P of x false.
When you assume.
Was there a question? Yeah, so if you're saying there's no values in the domain that make P of x true, that means every single one of them makes P of x false. Meaning it's really easy to find a counterexample. Just any one will work. Just pick any x in the domain, and that means P of x is false. So it's really easy to find this one x. There definitely exists an x in D. Just pick any of them. Does that help? Well, that makes sense. So I guess we can ask other questions after class or something like that. So let's move on and quickly kind of do the opposite of this with existential statements. Although I kind of made my piece a little bit. So existential quantifier, what time is it?